Now let's talk about regularization. As we said, regularization is a technique to help machine learning model to prevent overfitting. Remember this keyword, prevent overfitting is a technique to help you prevent overfitting. So when we talk about regression, we have some models. Some models allow you to apply regularization, and among them we have ridge regression and lasso regression. We talked earlier about linear regression. Linear regression. Linear regression doesn't have regularization, doesn't allow you to impose restriction on the model. Okay? Doesn't allow you to impose restriction on the model. So this is, they call it vanilla model. Vanilla model means a model that has no regularization capability. Okay? While if you like to apply regularized model, like in your assignment, you have regression case. Okay, so better avoid using linear regression, use instead ridge regression or lasso regression, or use both, of course. Don't use one model. You need to assess as many models as possible because eventually you don't know which model is going to perform well. So you try many. Anyway, when we go to the practical session, we discuss about this. So ridge regression is also known as Tikhonov regularization. Seems like Russian, maybe scientist. It is a regularized version of linear regression. It's used to avoid overfitting. So it has penalty part, allows you to penalize the model when the model overfits the data. Put some restriction. Lasso regression, on the other hand, is also regularized linear regression. To prevent overfitting, lasso regression is similar to ridge. Both of them has regularization technique to avoid or prevent overfitting. However, what does it do? It can shrink. This is the extra feature of lasso over ridge. Ridge, why it's better than linear regression? Because it has regularization technique you can use to avoid overfitting. Lasso regression has the same technique. However, it has the ability to shrink estimated coefficient. What is estimated coefficient? Like theta 0, theta 1, theta 2, right? Theta 1, not theta 0, theta 1, theta 2, theta 3, has the ability to shrink them, to reduce their value until 0. Why until 0? Because some features might actually might be redundant and cause overfitting. So when we shrink and the value becomes 0, so the feature becomes useless because any value multiplied by 0, the result is 0. Remember, like when we said earlier, why? Let's say if I have theta 0 plus theta 1 x1 plus theta 2 x2. And let's assume x2 is just a result of x1 plus 2. So it's redundant. It already has result of x1. So lasso regression is going to reduce theta 0 to become 0. So that means x2 becomes useless. Remember when we talked about feature selection? And one technique we talked about feature selection called embedded approach. Do you remember embedded approach? You can look back when we discussed about embedded approach. So lasso regression is considered embedded approach because he has the capability to eliminate some features by itself. Is it okay, Arvin? I feel you are confused a bit. So tell me where the confusion happens. I try to clarify. Which part you feel confused about? Sure, huh? Just if you remember when we talked about feature subset selection, and we said there are many techniques or approaches. One of them was embedded, which actually means the algorithm itself has the capability to eliminate or select some features. So since it can shrink the coefficient exactly 0, that means actually it's removed some features from the model. Okay, so it's used, as you see, lasso regression for feature selection. Okay, so it can help you to reduce feature selection because of the embedded approach it has. Attention, scaling data is crucial when you work with regularization regression. So if you work with regularized model, scaling becomes crucial. So you can use standard scalar, min-max scalar, and those kind of scalar. Okay, as the model is highly sensitive to the scale of the input feature. This is applicable to most regularized model as well. To address this issue, the recommended is to use standard scalar, or you have min-max scalar, for example, to ensure that the input features are scaled appropriately before applying the model. So when you talk about regularized models, like ridge regression, lasso regression, it's good to apply feature scaling before you train your model. Okay, so now the question is, which one we should use, linear regression, ridge, or lasso? As I told you, as a general rule of thumb, easy one, avoid linear regression, okay, because it has no regularization, okay, and take ridge and lasso, apply both. If you want to differentiate further, we can say usually take ridge, unless if you know you have many irrelevant features, then you can also look for lasso. But actually, you can apply both. You don't need to think much about it. Okay, and you have also another one called elastic. Elastic net is another algorithm for regression. Okay, which actually tend to be like ridge and lasso. Okay, predictors means feature. Don't forget, predictors means features, input features.